We've looked at a variety of ways of solving quadratic equations. One way that we can solve a quadratic is with something called the quadratic formula. The quadratic formula is one of the most well-known formulas in math, and it is very helpful for solving quadratic equations. So right here I have a generic quadratic equation, ax squared plus bx plus c is equal to 0. And when I have a quadratic equation in this form, then I can solve it or figure out what x is equal to using the quadratic formula, which is here beneath this equivalent sign in purple. The reason that I have the equivalent sign here is to illustrate that this equation here on top and this equation here on the bottom are equivalent equations. I've just manipulated this equation here into the quadratic formula here. And I'll show a proof in a later video that shows how we go from this version of the equation to this version. But what you need to know right now is that this right here is the quadratic formula. And you'll notice that I've highlighted the variables, the variable a, b, and c in specific colors to show how they're preserved from this generic quadratic equation to the quadratic formula itself. So let's see how this works in action. I'm going to write out a quadratic equation and we'll use the quadratic formula to solve it. So the equation is x squared subtract 5x. I'm going to try to preserve the colors here, so forgive me that this will take just a little bit longer to write out. X squared subtract 5x subtract 14 is equal to 0. Now, a couple things to note about this. First of all is that we have a coefficient of 1 for our x squared term, and so it wasn't written initially, but I'm going to write that in here. It was implied that we had a 1 here, but I'm going to write it out to be explicit. The other thing that I want to point out is that this equation is in standard form. It's in standard form because I have my second degree term, and then my first degree term, and then my constant term here on the right. So they go in decreasing order of degree: second degree, first degree, and 0th degree here. My a coefficient is 1, and so I'm going to write that out here, that a is equal to 1, and my b coefficient is -5. So b is equal to -5, and c, my c coefficient is -14. So I'm going to write -14 there. And now I'm going to copy the quadratic formula here, and I'm just going to replace b with -5 and a with 1 and c with -14. So let's go ahead and do that. And I'll preserve the colors here just so we can see where everything is going. So the quadratic formula is x is equal to -b, so negative, and then my b is -5, so -5, plus or minus the square root of b squared, so -5 squared, and I'll put the -5 in parentheses there just so we can keep the negative straight. So b squared, and then subtract 4 times a times c. So -4, and then a is 1, so times 1, and then times c, which is -14, times -14, and then all of that over 2 times a. And so that's 2 times a, which is 1. Okay, so I've replaced the variables in the quadratic formula with my particular coefficients for the equation that I started with here. And now all we need to do is simplify the right-hand side, and we'll find out the values for x. And rather than carry this through but with the colors, I'm just going to convert everything to just teal here. And so now I have on the left-hand side x, and then on the right-hand side I have negative of -5 is +5, and then plus or minus the square root of -5 squared is 25, and then -4 times 1 is -4, and then times -14, that's just going to be -4 times -14, which is going to be +56, so plus 56, and then 2 times 1 is just 2. And so that's the next iteration. And then I can simplify further from here. We have 5 plus or minus the square root of 25 plus 56 is, let's see, 61, 71, 81, all over 2. And now I have x is equal to 5 plus or minus, square root of 81 is 9. 5 plus or minus 9 divided by 2. And because I have this plus or minus sign here, there are actually two different versions of this equation that I need to sort out. One is when 9 is positive, and so I'll write plus 9 right there. And then the other one is when 9 is negative, so this is going to be the negative 9 version right there. And so now I have x is equal to 5 plus 9 divided by 2 for this version. And then for the negative 9 version, it's x is equal to 5 subtract 9 over 2. And 5 plus 9 is 14, divided by 2 is 7. And then 5 subtract 9 is negative 4 over 2, which is equal to negative 2. And so these are my two solutions. These are the two values that x can take in order to satisfy this equation. And so let me write out our solution set here. So that's x is equal to 7, or x is equal to negative 2. And if I were to substitute these two values back into our original equation, then I would get a true statement. I would get 0 on the left-hand side and 0 on the right-hand side after I simplified. Let's take a look at another one of these. So I'll make this disappear and bring up another screen. The next equation that I want to take a look at is 2x squared subtract 3x subtract 5 is equal to 0. And so here our a coefficient is equal to 2, so I'll just write this out so we can keep this straight. Our b coefficient is equal to negative 3, and our c coefficient is equal to negative 5. So now I'm just going to rewrite the quadratic formula here, but I'm going to replace these values, or I'm going to replace the variables with the values that I have here. So I'll keep the color consistent again. So that's x is equal to negative b, so that's negative, and then my b is negative 3, so negative 3 plus or minus the square root of b squared, so that's negative 3 squared, minus 4, and then times a times c, so times 2 and then times negative 5. Let's see, so times 2 and times negative 5 times negative 5. Those are all under the square root sign. Okay, and then on the bottom I have 2 times a, which is 2. And now I'll convert to teal here rather than maintaining the colors. Oh, this should be yellow. This is my C here. This should be yellow. There we go. Okay, so now all we need to do is simplify. I'll use the teal color from here on out. So on the left-hand side we have x, and on the right-hand side, negative 3 is equal to positive 3. So positive 3 plus or minus the square root of negative 3 squared is 9. Negative times a negative is a positive. And then we have negative 4 times 2 times negative 5. Negative 4 times negative 5 is positive 20. Times 2 is positive 40. So 9 plus 40. And then on the bottom we have 2 times 2, which is equal to 4. Then I'll continue this. X is equal to 3 plus or minus the square root of 49 over 4. And then the square root of 49 is 7, so this is 3 plus or minus 7 over 4. And so now we have two different versions of this equation, one where 7 is positive and one where 7 is negative. And so I'll branch out here. This will be the positive 7 version, and this will be the negative 7 version. And here we have x is equal to 3 plus 7, because this is the positive 7 version, over 4. And then here we have x is equal to 3 subtract 7, since this is the negative 7 version, over 4. And 3 plus 7 is 10 over 4. Which is, we can simplify to 5 halves. And now for the negative 7 version, we have x is equal to 3 subtract 7 over 4, which is equal to negative 4 over 4, which is equal to negative 1. So these are our two solutions for x, or in other words, the two values for x that will satisfy this equation that we started with. And so let's write out our solution set here. That's x is equal to 5 halves, or x is equal to negative 1. Both completely valid solutions to this equation. Okay, let's do one more of these. I'm going to make this disappear and bring up a blank screen. Now I have the equation 4m squared plus 8m plus 8m plus 7 is equal to 4. Now, a couple things that I want to point out right off the bat here. The first is that we can use the quadratic formula even when our variables, even when we don't have a named variable of x. Here our variable is m, and that's fine. The quadratic formula works just the same. The other thing that I want to point out is that the quadratic formula is defined when one side of the equation is equal to 0. Here it's the right-hand side. And so we cannot use the quadratic formula when the equation is in this form. It will not work. And so the reason that it won't work is because it's not set equal to 0 on the right hand side. And so I need to just combine my terms or remove this positive 4 from the right hand side before I can employ the quadratic formula. So I'm going to do that. I just subtract 4 from both sides, and then the new version of this equation is 4m squared plus 8m, and then 7 subtract 4 is 3, so plus 3 is equal to 0. So now my a coefficient is 4, so a is equal to 4. My b coefficient is 8, and my c coefficient is 3. Okay, so these are the values that I'm going to substitute into my quadratic formula. Now that I know what a, b, and c are equal to, I can substitute those values into the quadratic formula. The only difference is going to be that on the left-hand side, instead of x, we will have m, because m is the variable that we're working with. So that will be m is equal to negative b, so that's 8. So negative 8 plus or minus the square root of b squared, so that's 8 squared, minus 4 times a, which is also 4, times c, which is 3. And all of that over 2 times a, which is 4, so that is 2 times 4. Okay, and now from here, all I need to do is simplify the right-hand side, and that will tell me the solution or solutions for this equation. So m is equal to negative 8 plus or minus the square root of 8 squared, which is 64. And then negative 4 times 3, let's see here. 4 times 3 is equal to 12. 12 times 4 is 48, and so that will be negative 48. over 2 times 4, which is 8. And from there we have m is equal to negative 8 plus or minus the square root of 64 subtract 48. Let's see, 64 subtract 40 is 24, and then subtract 8 is 16. And then all of that over 8. And then for the next step here, we have m is equal to negative 8 plus or minus the square root of 16, which is 4, because 4 times 4 equals 16. And then all of that over 8. So now we have two versions of this equation that we can solve. One where 4 is positive and one where 4 is negative. So this will be the positive version, this will be the negative version. And so we have m is negative 8 plus 4 over 8, which is equal to negative 4 over 8, which is equal to negative 1/2. And then for this version of the equation, we have m is equal to negative 8 subtract 4 over 8, which is equal to negative 12 over 8, which is equal to negative 3/2. So these are our two solutions for this equation. So let's write those out formally. We have m is equal to negative 1/2, or m is equal to negative 3/2. Let me put a little box on that. So this is our solution for this quadratic equation. One thing that I want to add before I finish this is that there is a song, a helpful tune that someone has adapted for the quadratic formula, and it helps me remember. Even my daughter is learning it right now. She's 3 years old, so maybe it's a good way to remember this. And I will sing it, believe it or not, right now, and you can look up better versions of it later once you finish this video, but it's helpful for remembering it. I promise once you get it in your head, you won't be able to get it out. So the song is, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's all I got. Quadratic formula.